What if you could read a book, watch a movie, or take a nap on your way to work? What kind of future would that be? Welcome to the exciting world of autonomous vehicles, where artificial intelligence is transforming our day-to-day lives. But how did we get here and where are we headed? The journey towards self-driving cars started years ago. The dream of autonomous vehicles isn't new. It began with simple innovations like cruise control in the 1950s, giving drivers a taste of semi-autonomy. As the years rolled on, more advanced systems like parking assistance and lane keeping assist began to appear, nudging us closer to that dream. In the early 21st century, tech companies and automakers began to seriously invest in autonomous vehicle technology. Titans like Google, Uber, and Tesla, along with traditional automakers like General Motors and Mercedes-Benz, started developing systems that could sense and interpret the environment around them. Computer algorithms replaced human intuition, and cars began to see and think for themselves. The goal? To create vehicles that can drive from point A to point B with little to no human intervention. This ambition has brought us vehicles with varying levels of autonomy, from cars that can park themselves to prototypes that can navigate city streets independently. But the journey to full autonomy is a complex one. Artificial intelligence plays a crucial role in making cars drive themselves. At the heart of this revolution are sensors and perception systems. These include LiDAR, radar, and cameras, all working in harmony to help autonomous vehicles perceive their environment. Picture this. LiDAR acts like the car's eyes, enabling it to see the world in 3 dimensions. Radar, on the other hand, works like its ears, listening to the echoes of radio waves to detect objects. Cameras add another layer of perception, providing the rich visual context that enables these vehicles to understand the world around them. Now, how does an autonomous vehicle make sense of all this data? This is where machine learning algorithms come into play. These algorithms help the vehicle to process the data from its sensors, identify patterns, make predictions, and ultimately, make decisions. For instance, the vehicle might learn to recognize that a pedestrian is about to step onto the road, or that another vehicle is about to change lanes. Over time, as these vehicles encounter new scenarios and gather more data, they continue to learn and improve, much like a human driver would. But before these algorithms hit the road, they undergo rigorous simulation and testing. Virtual environments play a crucial role here, allowing developers to test these algorithms in a wide range of scenarios, from the mundane to the extraordinary. Imagine being able to simulate 1,000,000 miles of driving in a single day, or testing how your vehicle would respond to a kangaroo hopping across the road, all without leaving the lab. These simulations help to refine the algorithms, ensuring that they are ready to handle the complexity and unpredictability of the real world. However, with great potential comes great challenges. The road to fully autonomous vehicles is paved with technical hurdles, regulatory issues, and ethical dilemmas. But as we continue to push the boundaries of what's possible with AI, the dream of a world where cars drive themselves is becoming increasingly within reach. While the future of transportation looks promising, it's not without its hurdles. The road to fully autonomous vehicles is fraught with safety and regulatory challenges. These vehicles must strictly adhere to safety protocols to ensure the well-being of the public. The stakes are high, and every decision an autonomous vehicle makes can have serious ramifications. Moreover, the regulatory framework governing AVs is still in its infancy. Legislators around the world are grappling with the complexities of creating a legal environment that is conducive to the growth of this emerging technology, while also prioritizing public safety. Moving beyond safety and regulation, we must also consider the potential impact of AVs on our cities. Urban planning, infrastructure, and public transport systems will need to evolve to accommodate these vehicles. Imagine a city with fewer parking spaces, as AVs can simply drop off passengers and move on to their next task. Roads could be redesigned to optimize for autonomous traffic, and smart roads could communicate directly with vehicles to manage traffic flow. The economic implications are also significant. Autonomous vehicles could optimize transportation logistics, reducing costs and enhancing efficiency. They could disrupt existing industries such as taxi services and logistics, fundamentally changing the way we think about car ownership. From an environmental perspective, AVs could potentially reduce carbon emissions through improved efficiency and the use of electric powertrains. However, the production and disposal of these vehicles also pose environmental challenges that need to be addressed. The societal implications are equally profound. On one hand, jobs in traditional driving roles could be lost. On the other hand, new jobs could be created in the tech and management of AV systems. AVs could also enhance mobility for the elderly, disabled, and those unable to drive. Yet gaining public trust and acceptance of these vehicles on our roads is a significant hurdle. Yet despite these challenges, the future of AVs is full of exciting possibilities. Imagine a world where traffic jams are a thing of the past and everyone has access to personal mobility. This is not a far-fetched dream but a very real prospect with the advancements in autonomous vehicle technologies. In the foreseeable future, we might see the integration of AI with other cutting-edge technologies like quantum computing, enhancing decision-making speed and accuracy in autonomous vehicles. Nanotechnology could lead to self-healing materials, making our cars more durable and safe. Around the globe, different countries are at various stages of adopting and integrating AV technology. Nations like Singapore and the United Arab Emirates are at the forefront, investing heavily in this sector, while others are cautiously observing these pioneering efforts. The long-term vision for transportation, with fully autonomous systems, is not limited to just cars. We can foresee a future where autonomous drones and air taxis are as common as cabs today, transforming not only the way we commute but also the way goods are transported. This shift towards full autonomy will inevitably bring about significant societal changes. In a world where vehicles drive themselves, the concept of car ownership could become obsolete. Instead, we might subscribe to mobility services just as we do now with streaming platforms. There will be challenges, of course. Regulations will need to evolve, and public trust will need to be earned. But the potential benefits, increased accessibility, reduced emissions, efficient use of resources, make it a future worth striving for. The future of transportation is not just about getting from point A to B, it's about reshaping our cities, our lives, and our world.
Dive deeper into the realm of artificial intelligence with AI Knowledge Quest. Keep exploring, stay curious, and remember, the quest for knowledge never ends. Join us again soon.